All right, physical science class. No one is here. It's 10:30, so I'm going to go ahead and get started. I am recording, and I'm going to attempt to. Um, Hi, I guess I'll be teaching you.
Okay, I'm just walking through. Don't mind me.
I'm going to attempt to use this Jamboard I created. I wanted to review some concepts with chemical bonding. Uh, I just want to use it. I don't want to share it. I guess to view, send. Miss Kruger, can you see what's on my screen?
It's still loading, but I can see your screen. Now it's popped up.
Okay. I never know because I've tried to do a couple different things and can't get it to work how I want it to work. So I'm just going to go over things as if I'm teaching since nobody's logged on.
I understand, and I may not stay the whole time. Don't take it
Okay.
personally.
Oh, that's fine. All right, I wanted to review the periodic table, some things that we need to know about it. We need to know the group numbers. Ooh, I wanted to write. Get a pen. So group numbers, these are the numbers up on the top, and on the periodic table I shared with you in Canvas, these are labeled 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. So if your periodic table has the A's and the B's, and then down here in the middle, this section would have the B's with the numbers. If you have a periodic table like this one and it has 1 through 18, when you get over to 13, just ignore the 1 and you're going to look at the number in the tens place there. But the group number is telling you the number of valence electrons. This is very important for what we're going to be doing. Valence electrons are the electrons in the outermost energy shell. You've seen a couple videos on this so far. This is going to be very important for chemical bonding. So your group number is telling you that. And when we did Bohr models, your period number, these right here, are telling you the number of energy levels. So if we were drawing a Bohr model, these would be important here. But what we're going to do now, the period or the group numbers is what's going to be the most important. Also remember that your metals, if you look here, your metals are going to be group 1, 2, 3 through 12 is your transition metals. And I know on this chart they tell you that a few of these are your rare earth elements. Just know that these are your transition elements here in the middle, 3 through 12. And then you've got metals here in pink. And then you have your halogens or your nonmetals, and halogens are very important. The green column 17 and your noble gases column 18. They're unreactive. They have 8 valence electrons, so they are full outer energy shell and they will not combine with anything. Group 7 is very, very reactive. They're going to be a lot of bonding. They're most of these are, I think, they're gases as well. And then you have some of these in the orange here that are nonmetals, and then you have your metalloids, which aren't shown here, but they're going to border this yellow zigzag line right here. And so if it's a metalloid, a lot of times it will act like a metal sometimes, a non-metal other times. But you need to know kind of where the elements are. Are they considered a metal, non-metal, or metalloid in order to do what we're going to do with compounds? So the next slide I wanted to go over is where you've seen or should have seen a video on ionic bonding at this point and covalent bonding, just an overview. Atoms are going to bond because they want 8 electrons in their outer energy shell. and they're going to bond one of two ways, either ionic or covalent. Ionic means normally that you're going to have a metal, typically from groups 1 and 2. You can have some, the ones that we're going to deal with are from groups 1 and 2. Groups 3 will do, or group 3 through 12 will do a lot of bonding, ionic bonding as well. It's a little more complicated when we get to talking about oxidation numbers. But for most of the stuff we do, groups 1 and 2, it can be 3 through 12. And then the ones that are pink on that previous periodic table that we call other metals. So it can be any of those plus a nonmetal. Covalent bonds are two nonmetals, a metalloid and a nonmetal. And so that's one way to tell the difference. The other is that ionic will transfer electrons, and this is the symbol for electrons, E minus. These will share. And one of the videos talked about the various different covalent bondings that can occur, creating polar and nonpolar. We're not going to get that detail. Just know that they share electrons. And we're going to be looking at sort of how they do that. And the other thing under ionic bonds is you can have polyatomic, that we will talk about ions, and a metal can be bound with a polyatomic ion as well. You will have a chart where you have to put some characteristics of ionic and covalent bondings together. You also need to be able to recognize ionic bonds if you're given a formula. So if I gave you this formula right here, you would need to use your periodic table. You would need to know that calcium is in group 2, so it is a metal. So you would look on the periodic table and determine if it was a metal. You would know that chlorine is a halogen, it is a nonmetal. So if you had to identify this compound as a ionic or covalent compound, this one would be ionic because it's got a metal and a nonmetal. And this is going to take some time. You've got a sorting activity where you're going to have to do this. You will have to put which symbol is the metal, which is the nonmetal, and write if it's ionic or covalent. The same with, um, if we're doing covalent, it'll be two nonmetals. There may also be a chart that I'll need to upload of polyatomic ions so that you can see that. Um, we're going to do some more practice with those in just a minute. The other thing is, if you can see this, I know it may be hard until you go back and rewatch the video. You need to know various characteristics of covalent and ionic compounds. And this was also in one of the videos, but I wanted to pull this out a little and emphasize some things. Covalent compounds will have high melting points, so it takes a lot of energy to melt them. They tend to be solids and at room temperature, and they're not volatile, so they don't. I consider that as violent. So if I were to take a um, metal like sodium and put it in water, it's going to explode very quickly. Covalent compounds don't do that. Um, if they're in the molten state, they will conduct some electricity, but if you dissolve them in water, they will not. So that's the one that we're really important. This means aqueous solution dissolved in water. They do not conduct electricity. Um, most covalent compounds are soluble in water. But if you put them in in an organic substance such as like alcohol or benzene, they're not going to dissolve. But you just need to know usually dissolve soluble in water. Ionic compounds, low melting and boiling points. So it doesn't take as much energy to melt them or bring them to a boil. And then you have these tend to be liquids or gases at room temperature. Not always, but they tend to be, and they're going to be more volatile. And if they're in a solid form, they're not going to conduct electricity, but when they are dissolved in water, they will conduct electricity. Um, they are tend to be more soluble in organic solvents. So we're going to be able to dissolve those in things like alcohol or benzene. There are other characteristics. This was just one chart I found real quick to throw up here to go over a few things. This is probably the two biggies right here, and there'll be some others that you would have seen in a video. So I want to go back a minute and let me see who I have on. Left my meeting. Scott,
Morning.
good morning. You're in biology class. Yours was at 9:25.
Oh, my bad.
Yeah, it's fine. I'll have it posted as soon as my slow internet here at home uploads it. So you really don't have to sit in and listen to me teach myself here. You may want to pop into your second block though. I mean your third block.
Okay, thank you.
All right. Bye. All right. I'm gonna try again. Wanted to see who was in, so I want to just gonna start a new Jamboard this time. Um, so just some more identifying some elements. So if you were given NO2, you're going to again use your periodic table. N is nitrogen. You're going to see that it is on the right hand side, so it's a nonmetal. And O is oxygen. And you're going to also see that it is a nonmetal. If I have two nonmetals, I know it is covalent. One that has what we call a polyatomic ion in it, we have Na2CO3. If it starts with a metal, in this case it does, so sodium is a metal. This is going to be an ionic compound because it is bonded to these nonmetals here. So both of these here are nonmetals. So this is a nonmetal and this is a nonmetal. So you can say that this is an ionic compound because it is bonded to a polyatomic ion. But if we're looking at specific bonds, does it contain ionic or covalent bonds, then we would say that it would have both because between the two nonmetals, this is going to be covalent, but between sodium and CO3, this is ionic. So this would be both. So generally speaking, when it starts with a sodium with a metal, it's going to be ionic if we're talking about compounds. But if it's with a polyatomic ion, two other elements, nonmetals, then a lot of times you'll see it classified as both. Another way when you're glancing at these, if you see more than two capital letters in the formula, it is probably going to contain a polyatomic ion. And so in that case, you're going to want to look carefully and determine that. So I hope this helps you in the assignments that we have today. I'm going to try to go back again without exiting out of Google Meet. Um, I had, well, let me just call it up here. Um, had this set up a little differently from my other class. All right, so in the dashboard, you have for physical science, if you go to modules, probably the easiest thing to go to right at the moment, and we scroll down, mine, remember, you'll see more. Um, I don't have anything up for Thursday yet. I may not be online tomorrow. I will post a video so that you can know what you're to do at least. Some of you are behind, so you need to back up and make sure you've done for Monday the chemical bonding video. Talks generically about chemical bonds. You've got ionic and covalent bonds, a video that talks about that, and then a sheet for identifying ionic and covalent bonds. This was what I was doing those examples for in that Jamboard, showing you how to pick out your ionic and covalent bonds. You'll need a periodic table for that. You can either Google one or go back into the previous unit where I linked it for a file, and you'll need to use a periodic table for that. Yesterday, you're supposed to look at finding oxidation numbers, and so I'm going to scoot back over to the periodic table Jamboard in just a minute and talk to you about finding oxidation numbers. You're going to do this, look at that, look at your Lewis dot structures, how to do those, and then you've got to practice for both of those. And because I know that so many people were not at school Monday and Tuesday, we're going to concentrate on these two things today and tomorrow as well. So actually, I'll do the oxidation numbers in a separate video and post for you guys to watch tomorrow. That'll be your lesson for tomorrow. And then um, con- that's Thursday. Friday, remember, is a work day. There's no assignments, but anything within this unit you need to catch up with um, on Friday. Even though we're not assigning anything, it would be wise to do that. Now, if you owe me stuff from all these other units way back up here, you need to make sure it is given to me or turned in, submitted by Thursday. If you're having trouble accessing it, if you take a screenshot of the message that you get and email me, it will help out. You can also schedule a um, individual Google Meet with me if you go back to home. Remember, on the very home page, here's our links for our Google Meets. Down here, we've got book an appointment with Miss Noel. So you click on that and book that appointment. If you don't want to go through that, send me an email and I can respond and set something up for you. So today, work on Monday's work if you haven't done it. And I'll have this video up hopefully sometime today. My internet is working a little slow. Um, Let me get back over here. If you have any questions, remember to email me. I'm going to stop recording.